Salam, peace be upon you. My name is Muhammad Layiq Siddiqui, the father of Holophase, Part 40. Information as Constraint on Phi Pattern Possibility. We began with one insight. Pattern is primary. Phi is circular comparability, the root permission for distinction. Only relations are public. Identity is invariance under lawful transformation. Persistence is certified survival through change. Interaction is joint constraint. Time is ordered transformation. No ex nihilo. Every appearance has provenance. The observer is a pattern within pattern reality. Measurement produces traces. Memory stabilizes them. Models compress structure. Prediction narrows lawful futures. Learning updates structure while preserving identity. Intervention alters coupling. Computation transforms patterns under rules. Now we ask, what is information? 1. The word that tricks us. We use the word information as if it were a substance. We say information flows, leaks, is stored, is transferred, is consumed. We speak as if information were water in a pipe or electricity in a wire. But our discipline has been consistent from the first step. If a word makes us imagine a hidden fluid, we stop and ask what public structure that word is actually pointing to. So in this part, we do not deny everyday language. We simply reread it. Information is not a substance that flows. Information is constrained structure that reduces lawful possibility space under a declared context. What flows in communication is not information stuff. What flows are transformations, signals, traces, updates that carry constrained structure from one pattern system to another. This part installs that inversion, and it matters because it unifies everything we have done: prediction, stochasticity, measurement, memory, modeling, learning, intervention, computation. They are all about narrowing, shaping, and transporting constraints on what can happen next. The simplest intuition: a locked door. We begin with the door. A door can be open or locked. If it is open, many futures are possible. A person can enter, a dog can run out, a draft can pass through, a thief can slip in. If it is locked, many of those futures are no longer possible. What changed? Not the amount of information floating in the air. What changed is the constraint structure governing the next possible states of the house. Locking the door is not sending information. It is imposing a constraint. Now, imagine we do not know whether the door is locked. In our minds, we hold two branches. Branch 1 unlocked, branch 2 locked. When we check and see the key turned, one branch collapses for us. Our possibility space shrinks. Our planning changes. That shrinkage is information in the structural sense. Information is the reduction of possibility. Another example, the grocery list. A grocery list on our phone constrains our shopping. Without it, many futures. We forget milk, buy duplicates, waste money, spend extra time wandering aisles. With it, futures narrow. We follow the list. We move efficiently. We return with what we needed. If the phone battery dies, the constraint cannot couple into our window. The list still exists, but it is not information for us in that moment because it cannot constrain our action. Information is always a coupled constraint, not a floating property. Information as difference that matters. We often hear the phrase, information is difference that makes a difference. In this framework, we can make it precise. A difference is informative when it constrains what states and continuations remain lawful or plausible in a declared pattern space. If a difference does not constrain anything, it is variation without information. A scratch on a rock on a distant planet, never interacting with anything again, may be a difference. But if it never constrains any future transformation, it is not information for any window we can certify. Meanwhile, a tiny change in a traffic light from red to green is a small difference that massively constrains behavior. Cars stop or move. Accidents are prevented. Schedules shift. So information is not size, it is constraint power relative to context. Declaring the context. Information is not absolute. We have forbidden absolute phi. We now forbid absolute information for the same reason. Information only makes sense relative to a declared pattern space, what alternatives are in play, a declared window, what can be accessed, a declared transformation family, what counts as lawful continuation, a declared coarse graining, what distinctions matter and which are ignored. The same physical pattern can carry different information in different contexts. A book written in a language we cannot read carries little information for our window, even though it carries enormous information for a fluent reader. The ink patterns are the same. The constraint they impose on future belief and action depends on the decoding context. A DNA sequence carries information for a cell that has the machinery to read it. For a rock, it is just a molecular pattern. So we do not say this pattern contains X information without saying for which decoder, in which context, under which window, with which alternatives. Context dependence is not relativism. It is the same honesty we demanded for probability, energy, and entropy as derived readouts. The mailbox example. What actually moves? Consider a letter. We drop a letter in a mailbox. Later, it appears in another city. We say information traveled. But what traveled is paper and ink, physical pattern. The postal system carried that pattern through transformations, transport, sorting, routing. The information is the constraint the letter imposes on the recipient's possibility space. After reading, some futures become more likely, some plans become impossible, some actions become compelled. For example, a letter that says the meeting is moved to Monday removes many futures in which we arrive on Tuesday and still attend. So the flow is a pattern transformation chain carries a constraint bearing structure. Information is the constraint effect of that structure in the receiver's declared context. 7. A one-sentence structural definition. We can now write a compact definition we can reuse. Information is constraint structure that, when coupled into a pattern system through a declared window, reduces the lawful or plausible continuation set relative to a declared alternative space. This definition ties information directly to earlier parts. Prediction is the act of narrowing continuation sets using models. Stochasticity is disciplined uncertainty about which lawful branch is taken. Information is what reduces that uncertainty by ruling out branches or reweighting them. From prediction to information, the weather example. When a forecast says 60% chance of rain, we do not treat 60% as a substance in the sky. We treat it as a measure over a possibility space given a model and window. Now suppose we receive new satellite data. A storm front shifted. Our probability assignment changes from 60% to 20%. What happened? Did information fluid enter the atmosphere? No. The new trace imposed a new constraint on our model's continuation set. The space of plausible futures shrank and tilted. Information is that shrinkage and tilt. If we want a pronounceable equation for this connection, we can use a classic readout form, but keep it as a derived bookkeeping statement. I equals minus log p. It says, when an outcome that had probability p occurs, the information gained is proportional to the negative logarithm of p. Rare surprises carry more information because they remove more of the previous expectation space. In our discipline, this equation is not metaphysics. It is a certified readout formula relative to a declared probability assignment, which itself depends on window, model, and coarse graining. The library example: constraints layered on constraints. Walk into a library. A library is a constrained machine. The books do not push us physically, yet they constrain our mental futures, what we can conclude, what we can imagine, what we can build. But notice, a library only functions as information for an agent with a decoding window: literacy, language, attention, time. Without those, the library is just paper. So information is not inside the paper as a substance. Information is the constraint the paper can impose within a coupled system that can read it. In Phi Pattern terms, a text is a structured pattern that, under a particular decoding transformation family, maps into changes in internal model structure. That mapping is the information channel. 10. Raw variation versus informative variation. We now install an important distinction because confusion here ruins everything later. Raw variation is difference without certified constraint effect. Informative variation is difference that constrains. For example, the random hiss of static on an untuned radio is variation. It may not constrain anything we care about. It is noise relative to the task "hear the news." But if we switch to a tuned station, the sound variation now constrains our beliefs. We learn a score, a warning, a story. The same medium carries either noise or information depending on the encoding, the decoding, and the task. So, information is not the amplitude of variation. It is the structure of constraint relative to a goal and a window. Information and entropy, a clean relationship. Earlier, we treated entropy as a derived readout, coarse-grained multiplicity under finite access. Now we can say something simple. High entropy means many microstates fit the same macro description. That means weak constraint at the macro level. Low entropy means fewer microstates fit. That means stronger constraint. So information and entropy are linked through constraint. When we learn something that reduces the number of compatible microstates, we gain information in the constraint sense. If we want another pronounceable equation, again as bookkeeping, entropy equals log W. We pronounce it entropy equals log W, where W is the number of compatible microstates under a declared coarse graining. Then the information gain of learning a constraint can be described as the reduction in that log count. But we keep the emphasis. This depends on the declared coarse graining and window. The cosmic example: light as constraint carrier. A photon from a distant galaxy reaches a telescope. We can say information traveled for billions of years. What traveled is a pattern transformation, an electromagnetic wave packet propagating through space, then coupling into a detector, producing traces. The information is the constraint those traces impose on our model of the galaxy: its redshift, composition, motion, age. Cosmic information is not a cosmic fluid. It is constraint transfer across enormous transformation chains. The universe is full of such carriers: fossils, rings in wood, isotopes in ice cores, layers in rock, background radiation. They are persistent traces. When coupled into an observer system, they narrow possibilities about the past and about lawful dynamics. Information is memory made usable. Information and measurement. Traces become constraints. Part 33 said measurement produces traces. Part 34 said memory is persistent trace structure. Now Part 40 says, information is the constraint those traces impose on possibility sets. So the chain is coupling produces trace. Trace persists as memory. Memory constrains future transformations. And that constraint is information. In other words, information is not a new ingredient. It is the constraint role of stable traces within a certified window. A thermometer reading is a trace. Once read, it constrains what we believe about the temperature, which constrains what we do next. Wear a coat, turn on heat, cancel a plan. The reading did not contain information stuff. It was a pattern that constrained planning. Information and control. Steering is constraint engineering. Part 38 said control is constrained steering of continuation sets. Now we can say control is the active creation and placement of constraints to reshape possibility space toward a target. A thermostat controls temperature by imposing a constrained regime, heater on or off based on a measured threshold. A dam controls a river by imposing boundary constraints that alter flow patterns, erosion patterns, ecological patterns. A law controls behavior by imposing social constraints, penalties, and permissions. In all cases, what is engineered is constraint structure. That is, information in action, not as substance, but as a structured restriction and guidance of possible futures. The puzzle piece example. A child tries to complete a jigsaw puzzle. Before placing a piece, many locations are possible. When the child notices the piece has a straight edge, possibilities reduce. It must be on the border. When the child notices a blue pattern, possibilities reduce. It likely belongs in the sky region. Each noticed feature is information because it constrains the set of lawful placements. No substance moved, a constraint was recognized. Information is the narrowing of where this can go under the puzzle rules. This is the same structure as prediction. We narrow futures under rules. The courtroom example, evidence as constraint. In a courtroom, a fingerprint is treated as information. But again, nothing mystical happens. The print is a trace, a pattern left by interaction. It becomes memory, stored on paper in a database. It becomes information when it constrains the possibility space of who touched the object, but only relative to declared context. What alternative suspects exist? What window produced the print? What error rates apply? What transformations could distort it? What background prevalence exists? A weak print may only slightly constrain the suspect set. A strong match may constrain it sharply, but neither is absolute. Context and uncertainty matter. This example shows why our information gate is not academic. Without declared context, evidence becomes theater. With it, evidence becomes public constraint. Three layers we must not confuse. Because information is overloaded, we install a three-layer ladder. First layer, constraint information. This is what we have defined in this part. It is the structural reduction of possibility space. Second layer, coded information. This is how constraint is packaged into an encoding so it can be carried by a channel. Ink marks, voltage levels, sound waves, gestures, DNA bases. Coding is a communicational layer that sits on top of constraint, but it is still pattern structure. Third layer, semantic information. This is meaning, what a constraint does to goals, values, interpretations, and shared understanding. Semantic information requires a community of decoders and norms. It is real, but it is a later layer. We do not smuggle it into part 40. A simple example keeps this clean. A red traffic light is constrained information. It forbids go now. The red color is coded information, a wavelength pattern used as an encoding. The meaning stop for safety and law is semantic information, a social layer that depends on shared rules. If we confuse these layers, we either mystify information as spirit or we reduce meaning to mere physics. Our framework refuses both errors by separating layers and then showing how they connect. No alternatives, no information. One more subtlety completes the spine. Information requires an alternative space. If there is only one possible state in the declared context, then no constraint can reduce possibilities because there were no possibilities to reduce. This is why null is not pessimism, it is discipline. If our window cannot distinguish between alternatives, then we have no information about that distinction. We may still have raw variation, noise, fluctuations, ambiguity, but not informative constraint. A simple example: a coin sealed inside an opaque box. If our window cannot access the coin at all, then heads and tails remain equally live. We can talk, imagine, guess, but our possibility space has not been constrained by any public trace. The information is null. Now open a small hole and let light in. We see a glint, but not the face. Our space narrows slightly. Maybe the coin is metal, maybe it is not. That is small information. Open the box fully. We see heads. The alternative tails is eliminated. That is strong information. So information is graded by how much the alternative space shrinks under lawful coupling. The information gate. Now we install the rigor layer for information claims. An information claim must pass the information gate. It must declare the context. What pattern space of alternatives is being constrained? The window. How the constraining trace is accessed. 3. The constraint type. What is ruled out or reweighted? 4. The transformation family. What continuations count as lawful? 5. The coarse graining. What distinctions matter and which are ignored? 6. The link to prediction or control. What uncertainty is reduced and how this affects forecasting or steering. If these are missing, the claim "this carries information" is not certifiable. It is an impression. 20. Firewalls. What we refuse. We refuse. Information treated as a substance that flows. Context ignored. Variation conflated with information. Semantic meaning smuggled as primitive at this layer. Constraints asserted without specifying the alternative space. Claims of more information without declaring what uncertainty was reduced. Evidence treated as truth without declared alternatives and error bounds. These firewalls do not reduce information, they purify it. 21. What Part 40 gives us. By the end of Part 40, we have information as constrained structure, not substance. Context dependence installed. A clean link to prediction, stochasticity, measurement, memory, modeling, learning, intervention, and computation. A clarified story of flow. Transformations carry constraints. A three-layer ladder preventing smuggling. A gate for certifying information claims. A direct bridge to communication. Because once information is constrained, the next question is obvious. How does one system transfer constraints to another? That is communication. Constraint transfer under encoding, channel noise, decoding, and shared certification. A final image, the lighthouse beam. A lighthouse sends pulses of light. A sailor sees the pattern. 2 flashes, pause, 1 flash. What traveled is light. What arrived is a trace in the sailor's eyes. What changed is the sailor's possibility space. Rocks are near. Safe passage is here. Information is not the beam. It is the constraint the beam imposes on navigation. We began with comparability. From phi emerge distinction. From distinction emerge pattern. From pattern emerge identity, persistence, interaction, measurement, memory, modeling, prediction, learning, intervention, computation. And now, information. Information is not a new ingredient. It is the constrained role of stable traces within a certified window. It is what makes prediction possible, what learning refines, what intervention engineers, what computation propagates. It is pattern all the way. We now move forward. With information installed as constraint, we can finally understand communication as the lawful transfer of constraints across systems. That is part 41. This has been part 40 of the Phi Pattern Science Foundation. The journey continues with part 41, communication as constraint transfer. Always, peace be upon you.